Hi, this is CIS 125, and this is a review, so mostly of items from week 5 through 7. And it also has a little bit of the information on the problem, the programming problem or design problem in the first exam. Alright, so we're going to get started here. This is review. These are the control structures we should know. We should understand sequence, conditional, and then iteration, whether it's a leading or trailing decision. Some people are confusing. They're using an if statement for these two. These would be a do while for the leading decision and do until for the trailing decision. And so it's this whole idea of iteration or looping. And then we also covered case structure. And I'll review that here in a little bit. We reviewed managing boxes, a start, and a stop, one arrow out, one arrow in. These boxes, one arrow in, one arrow out. And then a decision box, one arrow in, two arrows out, and it must be either true or false, or yes or no. And you have some conditional in there. Alright. And I reviewed these structures and talked a little bit here, a leading decision. You have all the processing, then you come back up, there's no processing in here. And this would be a do while. We looked here, some conditional, we're coming in, causes us to be true or false. Now in this case I put in a nested if, and you notice this comes back together and then this one comes back together. That can be a little bit difficult, but you'll notice the red here is a decision. We have a true part, a false part, and those come back together. Inside there, like the blue, we have a decision, goes two directions, comes back together. Alright. And then I reviewed the whole structure here again. In the exam, some people, when they talked about gender, they said gender is equal to M. We have a variable and a variable. What they meant probably was this. You got to indicate that as a string. So we spent the beginning of a particular day talking about that. Talk about the difference. You're either storing a numeric or you're storing a string, and they're both stored in memory differently. They're both stored differently. So a storage location in memory, really the operating system figures out where it's going to keep track of data in memory. You got a program executing up to the processor, the instructions get processed and back down the memory, and if those instructions need to reference a memory location, it can do that by using a variable. We use a variable name, but the operating system actually figures out where it's going to put it in memory. It stores strings, entirely different than it stores numerics. Has to store numerics, like an example would be with a characteristic in mantissa, and so the processor, when it brings those numbers up into the processor and puts it in registers, they can actually add, multiply, divide, and subtract. Strings, we just, like in a PC, it's usually an ASCII code. This is a capital A, and this is capital B, according to ASCII code. Now in programming, some programs allow us to, all programs probably in some way or another, you can declare variables, or we'll use the word initialize them. You can, actually declaring would be more defined, where you say the variable is going to be this kind of variable, it's going to be this big, you know, you need this much space. We can initialize variables, which is really important. If you have a variable, I'm over here on this formula, here we have a variable on the right side in a formula, that should have a value. Both of these should have a value before it calculates this. Right here. Everything on the right side of an equal sign should have a value. And we should always keep in mind, distinguish between, is it representing a string or a numeric. Then we had that example before. Alright, I reviewed opcode. Make sure in here is just the variable, and that variable, if that variable then will need to match these values. Okay, so that variable will contain what we put here for values. And then the opcode can go down and find that and then execute the code following it. So here we have some type of variable containing, if MC contains 3, then it's going to go here and execute this information here. So you have to have a variable there, and from somewhere previously, that variable has to obtain a value, and that value needs to occur over here. If it doesn't occur, then it'll do the other, whatever you have programmed to do there. Okay. You should always indicate your flag in the legend. Make sure, like this, doesn't mix, you know, if A is a number, if you're storing, you know, numbers there, then you can't flag that to a string. Can't flag that to a string. Make sure you follow your program, should flow down and to the right as best you can. Sometimes you'll have to use an on-page connector to go, you know, from here X and then come into this X here. This is an off-page connector, and if you need to define it better here, but make sure what you use in here then on the next page, it would look like this. Make sure you use the same thing so you can match it up. And then you can always do a description and clarify where you're going. So it should be easy to look at a program and see how it flows down and across without getting lost and trying to find where you're at. Here's an example on the test. If you're comparing gender, now we're comparing it. This is the variable, and it's a string variable because we're going to compare it to a string. And then you got to make sure you define how you're going to enter gender. Some people actually typed in the word male. Then this here would have to be male. And some people just had them put in a letter, either an M or an F. Alright. We did this example. We started this on the board. We didn't, you know, we weren't done yet. For example, in the legend, we still need the total age of males, total age of females, and then the flag, we're going to use done for gender. And we would describe that. Okay, write that out. And so we're inputting gender and age. We're going to add up these things. We're going to add up their ages. We're going to add up their ages, and we're going to add up how many they are. And we can do that in a looping process. Once we get that done, then we can go ahead and calculate these items and print it out. Here's the first part. We initialized a bunch of variables. We're going to input gender. We define that it has to be an M or an F. You could make that much more clear if you wanted to. And then we enter our loop. While gender is not equal to done, that's true. We're going to grab the age. We're going to check the gender. If it's male, we're going to add up the males. If it's females, we're going to add up the females. Both how many, a count and a sum, a count and a sum. And, you know, you can check to see if I had any errors there. Okay, then we're going to come back. We're going to grab another gender, and then here's my X. Here's my X, and so we go back into the loop. So we go into the loop, and then we either go this way or this way. We finish up the conditional, come back here. The X leads us back over here. We're going to loop. Once we enter done here, it's going to cause this to be false. And then we go to Y. And then in Y, we get the, we've already accumulated these items. So they all have values, so we can figure out the average age of the females, the average age of the males, and the overall average. Add the ages together and divide it by how many. And then print it out. Assuming I didn't, you know, miswrite something or get my variables mixed up, that would be a solution. And I didn't write a pseudocode for that. But if you need one, we could write that in a pseudocode too. And look at that. And that is it for the review.